pivotal role in chemistry, particularly in material science and polymer chemistry. It refers to elastic polymers known as elastomers, which exhibit remarkable flexibility, durability, and resilience. The use of natural rubber dates back to ancient times, with indigenous peoples in Central and South America using latex extracted from the rubber tree, which is also known as Hevea brasiliensis. Chemically, natural rubber primarily consists of polyisoprene, a polymer of isoprene. The main question here is what exactly is rubber? Rubber is an elastic material composed of long-chain polymers known as elastomers, which have the unique ability to stretch and return to their original shape when released. It can be sourced from natural materials such as the latex of rubber tree or produced synthetically from petroleum-based compounds. Rubber has several defining characteristics, including elasticity, where rubber can be stretched significantly and still return to its original form. Next, the durability, where it resists wear, tear, and harsh environmental conditions, making it highly versatile. Rubber is also waterproof, means rubber is impervious to water and many chemicals. And lastly, rubber is non-conductive, where it serves as an excellent electrical insulator. There are two main types of rubber, which is natural rubber and synthetic rubber. Rubber is widely used across various industries, including automotive, healthcare, construction, and consumer goods. Its unique properties make it indispensable in daily life, and ongoing research seeks to enhance its sustainability and performance.
The characteristics of natural rubber depend on rubber polymers. They are natural elastomeric polymers. The first characteristic of natural rubber is soft. It is a soft white solid at room temperature. Second, elastic. Natural rubber can be stretched and can return to its original shape when released. Third, it has low heat resistance, where at high temperature, natural rubber will become soft and sticky. Next is electrical insulator. Natural rubber cannot conduct electricity and is a good electrical insulator. Then, natural rubber is easily oxidized and reactive to chemicals. It reacts easily with acid, alkalis, and organic solvents. Lastly, natural rubber is waterproof. The next one is coagulation of latex. Latex is collected in liquid form for processing, or it can be left to coagulate and to be collected a day after it was tapped. The collection of latex in liquid form should be done quickly because once exposed to the air for a few hours, the latex will start to coagulate and turn solid. So how does the coagulation process happen? It started when negatively charged protein membrane causes rubber particles to repel each other. Then, hydrogen ions from acid neutralize the negatively charged protein membrane. After that, rubber particles collide with one another that causes the protein membrane to break. Lastly, rubber polymers combine with one another that causes latex to coagulate. Coagulation can take place by adding weak acid into the latex, or it can be occur naturally by leaving the latex exposed to the air, and the bacteria in the air enter the latex and secrete acid, which eventually causes the latex to coagulate. Besides, we can prevent the latex coagulation by adding alkaline solutions such as ammonia to ensure the coagulation does not take place. Alkaline solutions consist of hydroxide ions that can neutralize the acid produced by the bacteria. The protein membrane of rubber particles remains negatively charged, and rubber particles will continue to repel when they draw near one another.
Vulcanization of rubber. Vulcanization of rubber is a chemical process that involves treating raw rubber with heat chemicals, typically sulfur, to improve its elasticity, strength, durability, and heat resistance. The process transforms the rubber from a soft, sticky material into a more robust, elastic, and stable substance. Vulcanization process. Basic concept of vulcanization. Vulcanization is the process of cross-linking the individual polymer chains in rubber to form a three-dimensional network of interconnected molecules. This network provides the rubber with its characteristic properties such as enhanced strength, elasticity, and resilience. Vulcanization of rubber. Vulcanization process, which is raw rubber and unvulcanized rubber. The rubber used for vulcanization is typically natural rubber or synthetic rubber, like styrene, butadiene rubber, or neoprene. Raw rubber is inherently sticky and lacks the mechanical properties needed for practical application. Without vulcanization, rubber would remain too soft, not elastic, and prone to degradation under heat or stress. The primary ingredients used in the vulcanization process include sulfur, accelerator, activators, plasticizer and oils, and fillers. As you can see from the picture, which is figure 4.8, vulcanization of rubber to form sulfur crosslink. During a vulcanization process, the double bond between carbons found in rubber molecules will react with sulfur or other substances to produce sulfur crosslinks as shown in figure 4.8. The sulfur crosslinks make vulcanized rubber stronger. Next is alternative vulcanization methods. Vulcanization by using sulfur is the main method used to produce vulcanized rubber from natural rubber. Nonetheless, these vulcanization methods cannot be used for certain types of rubber, particularly synthetic rubber, which does not contain carbon double bond with carbon. There are a few alternative vulcanization methods that can be utilized to produce vulcanized rubber without using sulfur, as shown in figure 4.10. Vulcanized rubber produced is free from sulfur and more environmentally friendly. The next one is properties of vulcanized rubber. The first one is improved elasticity. The second one is enhanced strength, and the third one is better durability. The first one, improved elasticity. Vulcanization rubber can return to its original shape after being stretched or compressed, making it ideal for products like tires, seals, and gaskets. The second one, enhanced strength. The rubber becomes stronger, more resistant to wear, and capable of withstanding physical stress. And the third one is better durability. The process improves the rubber's resistance to aging, oxidation, and degradation from environmental factors like UV rays, ozone, and weather. The last one is the different illustration on the elasticity of vulcanized and unvulcanized rubber, and the differences between vulcanized and unvulcanized rubber. You can see the difference on the table given.
What is synthetic rubber? Synthetic rubber is a synthetic polymer that is elastic in nature or elastomer polymer. Most synthetic rubber is produced as byproduct of petroleum. It is used in many industries, including automotive and also in construction. The properties of synthetic rubber is similar to natural rubber, which is it can be stretched and returned back to its own shape. However, synthetic rubber has varieties with its own performance attribute. Synthetic rubber have 6 characteristics. Firstly, it's hard, resistant to heat, heat insulator, resistant to oxidation, elastic, and the last one, resistant to chemical. The unique characteristic of synthetic rubber can form a lot of items that can be manufactured. So here is the example. So the first one is neoprene. The characteristic is it has high heat resistance, oxidation, and flame resistant. So the example is petrol rubber hose. The second one is styrene butadiene rubber, which is SBR. The characteristic is abrasion resistant and high heat resistant. The example product is tires. The third one is silicone rubber, which is it have high heat temperature resistant and inert. And the example product is automotive compartment. Okay, Thiokol and nitrile rubber, both of these rubber have same characteristic, which is oil and solvent resistant. So the example product for Thiokol is Sealant, and for the nitrile rubber is Glove. Why rubber is used commercially? This is because rubber is naturally resistant to many things, including heat and cold temperature. This is the reason we make the rubber as it become an ideal item for use in many parts of our environment. The flexibility of rubber has come from the substance that contains carbon bond and carbon double bond. This carbon bond will make rubber have extraordinary flexible, stretchy, and resistant to from breaking and cracking. Other than that, rubber also has a high tensile strength. This will make it ideal for use for our industries that require the absorption of shock, such as in the construction industry. Rubber can be a protector for the workers and also for the machine. So this is because rubber has a coefficient of high friction.